Welcome back to the embedded system class. In this class I am going to explain about pull up and pull down resistors and memory mapped peripherals. So pull up and pull down resistors, so mainly these are used to maintain logic 0 and logic 1. So these are the two blocks. Pull up and pull down resistors are used to maintain proper logic levels at the input pins of microcontrollers under all conditions. Means if it is logic 0 means the output at microcontroller is 0 volts. Logic 1 means high level means output is VCC. So to maintain proper logic levels we use pull up and pull down resistors. So pull up or pull down resistors can be activated by setting corresponding bits in GPIO pull up resistors. Using this pin we can set pull up resistor logic 1, and GPIO pull down resistor we use GPIO PDR bit. So as in previous class I explained IO multiplexing. Each IO pin acts in two modes, port mode and alternative mode. So these are alternative mode pins. GPIO PUR is for pull up resistor, GPIO PDR for pull down resistor. So this is block diagram of pull up network resistor and pull down resistor. So the resistor, load resistor is connected to microcontroller, and from microcontroller, so in between microcontroller resistor and ground we use a switch. So whenever this switch is in open circuit, so whatever the voltage flows through our pull up resistor, there is no path to go to ground. So whatever the voltage we are giving, all the voltage is going to microcontroller. So the output is 5 volts. So that we can maintain logic 1 as high level, high as 5 volts. So coming to second one, so this is nothing but pull down resistor. So in between VCC and microcontroller we use a switch, and that we use a resistor or pull down resistor. So in this, so it is nothing but a pull down resistor. So it is used to maintain logic 0. Logic 0 means the output at microcontroller is 0. So we have to maintain 0 voltage. So we are giving VCC. Whatever VCC we are giving, so it is not come to microcontroller unit, because in between VCC and microcontroller unit we use a switch. Always this switch is in open. So there is no path to flow that VCC to microcontroller unit. If at all any voltage is there, so using this pull down resistor, we connected this pull down resistor to ground. So whatever the voltage there, so all the leakage voltage will be go to ground. So in microcontroller, in pull down resistor, the output is 0 volts. So these two, pull up resistor and pull down resistor, are used to maintain a proper logic levels at the input pins of microcontroller under all conditions. So constant pull logic 1 means 5 volts and constant logic 0 means 0 volts. So next topic is memory mapped peripherals. These are two complementary methods of addressing IO devices. There are two complementary methods addressing IO devices and peripherals. I discussed interfacing. What is interfacing? Different types of interfacings. So we have two types of interfacing, two types of addressing IO devices and external memories. There are memory mapped and port mapped. So in port mapped we need to connect separately IO devices, and we need to connect IO devices and memory separately. So we need to use separate data bus, address bus, control bus to access IO devices, and we have separate data bus, address bus and control bus for memories. So here we need two different buses, so that the delay also very high. So we use memory mapped IO devices in embedded systems. In MMIO, IO devices and peripherals are mapped into the same system memory map. So that is a common address bus for memory and peripherals. The control signals used for memory operation and IO operation are same. So as I explained earlier, so here IO and memories are inserted in a same address, so that we use only a single data bus, we use only a single address bus and only one control bus. So there is no separate buses. So here we use a single bus to access data, to access address and to access control. So there is no delay in memory mapped IO devices. For TM4C microcontroller, our peripheral devices, timers and ADC are mapped as MMIO in address space. The address space is 0x402 to 0x400F. So this is example, right? So TM123, so RAM is 256 flash memory and 32 RAM memory and IO ports. See here, IO ports also include in the same memory address. So and internal IO PPBs, peripheral buses. If at all any internal IO devices are there, external IO ports are there, RAM and RAM, all those devices are inserted in a single. So using a single bus we can access this. So second, this one is nothing but TM4C 129. The memory is for flash memory is 102K RAM, so 256K for RAM. Different types of IO devices, internal IOs, all IO and memories are inserted in a single address, which is nothing but 0x4000 to 0x4000F. So that is the address of each RAM, ROM, IO devices, memory mapped IO devices. So this is about pull-up resistor and memory map. Thank you so much.